Alright, we're going to be evaluating some expressions today. Again, this is all review, and so it ought to be pretty straightforward, I hope. What if they throw something like this at us? Evaluate this expression excuse me, for x equals 3, y equals negative 3. So they just want us to replace the x's in here and the y's and get some number. Okay, so let's do that. So I've got 9 times x. Well, x is 3, they say, so I'm just going to replace that. Plus 3 times x, well 3 again goes in there for my x, times y is negative 3, and then minus 2. So now again you just do this pretty straightforward, or go plug it in a calculator. So I get 27, 3 times 3 is 9, times negative 3, so that's negative 27, and then minus 2. So 27 minus 27, 0, minus 2. Of course, negative 2 is where we end up. And again, you can go plug that in a calculator, but I encourage you to work through it. Not too bad. How about this? Just basic parts of an expression. Again, pretty straightforward. Sorry, I just drug that there. Let me grab that. Sorry about that. So parts of an expression. If we see some algebraic expression, like we just saw in the previous slide, x plus y plus z, whatever. In this case, 4a plus 2b plus 3. Each of these makes up what we call a term. So this would have 3 terms, okay? And these are all the same. So this would have 3 terms. The coefficients are just the numbers out front, okay? So the numbers attached to a variable. And what's a variable? Well, of course, a variable, in this case a and b are variables, they can represent different numbers, right? X and y are variables that we use very commonly. So coefficients, just those numbers out in front of a variable attached to it. If you don't see a number in front, then it's a 1, right? And then, of course, this guy at the end, if there is one, that doesn't have a variable with it, is simply called a constant term. So there is no variable there. So we just want to differentiate between terms, coefficients that are part of a term, right? And of course a constant term. Not too bad. Okay, like terms, something that certainly you've heard of. Again, I hope this is real familiar. These have the same variables raised to the same powers. To be like terms, their variables and powers have to match exactly. And this allows us to simplify expressions. So which of the following are like terms? X, y, y, z. Do those match? No, because this one doesn't have an x, this one doesn't have a z. So those are not like terms. X cubed y, 3x cubed y. So, x to the third, x to the third. Hey, those match. Y, y. Those match. So these are like terms. Notice they have a different coefficient, a different number in front. That's okay. We're looking, do the variables and powers match? And those do. 3x, 3y, no, those are different variables, right? xy cubed, x cubed y. Hey, those don't match, right? So they're trying to trick you a little bit. But variables and powers have to match exactly. Let's simplify an expression. This really builds on like terms. 12a minus all this minus b. Now here's a common little thing I see pop up that gets us. This minus here applies to everything in parentheses. So let's distribute it through. Let me just rewrite this. So that's the same as 12a minus 4b minus 4a minus b. And now let's just combine like terms, right? Well, 12a and 4a match here. So 12a minus 4a would be 8a. Negative 4b minus b would be minus 5b. So 8a minus 5b, and then let me go, looks like this one matches. Okay, and this is the way I would encourage you to do problems as you go through this class. Even though it's online, even though they're multiple choice, a lot of them, work it out on your paper, think your way through it, and then go look at the choices. Don't look at the choices first, okay? This is going to help you analyze things, help you have some good notes, problem-solving strategies you can build on as you move forward.